Okay, so I asked you to do on the more torque question sheet numbers 1 to 4. I'm thinking that a couple of them might have caused you issues. So number 1, 4 young people are playing on a seesaw. So draw your nice long plank. Only nice long because you need to put 4 on it. Okay, 2 masses 30 and 40 kilograms are on either end. Okay, so FG1 is on this end, FG2 is out on this end, M1 is 30 kilograms, M2 is 40 kilograms. And it says 5 meters long, so both of their R's are going to be, or it says 10 meters long, so both of their R's are going to be 5 meters because they're out on the end. And it says the fulcrum is placed exactly in the center and it's uniform. So again, we can ignore the F of the fulcrum and the F of the plank. A third 50 kilogram youth, so M3 is 50 kgs, is 3 meters from the fulcrum on the side of the 40 kilogram person. So FG3 is on the same side as what I called M2. So R3 is 3 meters from the fulcrum, so 3. Where should the fourth youth of mass 55 kilograms sit to balance the teeter-totter? So M4 is 55 kilograms. And hopefully you know they're going to have to sit over here. And then we just need to find the where. So you're going to do sum of the torques is equal to 0. So there'll be a torque from 1, a torque from 4, I'm just going to go in the order, torque from 3, and a torque from 2 equal to 0. Assuming our fulcrum is the pivot point, 1 and 4 make it rotate counterclockwise, so they'll be positive. 3 and 2 make it rotate clockwise, they'll be negative. And so it's R1 FG1 sine theta 1 plus R4 FG4 sine theta 4 minus R3 FG3 sine theta 3 minus R2 FG2 sine theta 2 equals 0. All of the thetas are going to be 90, so all of the sine thetas are going to be 1. So then this will be R1 M1G plus R4 M4G minus R3 M3G minus R2 M, oops, I wrote them backwards, but G. Every term has a G in it, so it can cancel. You're solving for R4, so take all the rest over and divide by M4. So it'll be R3 M3 plus R2 M2 minus R1 M1 over M4. Try to get your numbers in the right spot, okay? So R3, I say that and hopefully I will too, 3 meters times 50 kilograms. R2, so it's plus 5 meters times 40 kilograms. R1 minus 5 meters times 30 kilograms divided by 55 kilograms. And you should get an R4 of 3.636 meters. Works out to be positive, which means I put it on the right side. If it had worked out to be negative, it would mean I would have had it on the wrong side. Okay, number 2 is one of the ones that probably caused issues in your life. A wooden plank of length 6 meters and mass 90 kilograms is resting on top of 2 sawhorses. Now, question is, do you know what a sawhorse is? If you have anybody who's into carpentry in your life, you probably do. A sawhorse is a plank that's supported on like 2 legs like this. And carpenters and people who build things usually have 2 of them in their workshop. And so then they can take like a long board and lay it over the top. And then they can cut in the middle without cutting like the workbench, which otherwise you would set it on or the floor. Okay, so these are called sawhorses. You can imagine they could have a head here with a mane, and they'd be a horse. Okay, so you have this setup then, and so just redrawing it without the sawhorses. But so one is going to be pushing up with a force. Oh, actually, let me not say that right now. Okay, sorry. Let me go back to what we have first and read the question before I confuse you. And my whiteout won't work. All right, so we have this setup, and it says your brother Throckmorton decides to stand on the right end of the plank. If the plank is to remain at rest, how massive, what's Throckmorton's mass must be. Okay, so Throckmorton is like standing on the board, and you and your friend say, hey, we'll give you a toonie if you see if you can walk out all the way out to the end without tipping the board. Okay, so that's what he's going to do. So if we look at the board, and I'm just going to draw it bigger up here. Okay, the trick here is if he's standing out on the right-hand end, just as it's about to tip, this second pivot point, like so, it's resting almost like it's resting on two fulcrums. And when he's standing out here with his weight acting down, Fg of Throckmorton, as this is just about to rotate, this becomes the pivot point, and this one isn't even touching, right? When it's about to rotate, all of the weight is off this one, and it's this fulcrum that's holding it all, and that's the trick. Okay, it's a uniform board, so Fg of the board will be here. Okay, and really this one does nothing, and you can use this as your fulcrum. So now when you do sum, we could call this, well, maybe I'll call this one number 1 and this one number 2. So when we do sum of the torques is equal to 0, the torque for number 2 is going to cancel out because there's no force. There's the torque from the board, the torque from number 1, which is going to cancel out because it's the pivot point, and then the torque from Throckmorton has to equal 0. If number 1 is my pivot point, this guy is going to be positive and this one negative. So we're going to have R of the board, Fg of the board, sine theta of the board, minus R of Throckmorton, Fg of Throckmorton, sine theta of Throckmorton. And if the board isn't tipping, the thetas will be 90. So we'll have R of the board, M of the board, G, minus R of Throckmorton, M of Throckmorton, G. Again, the G's will cancel, and this time you're solving for the mass of Throckmorton. So take it over, it becomes positive, and then divide by the R of Throckmorton. So R of the board, M of the board divided by divided by R of Throckmorton. The board, it told us, was 6 meters in length, and so the center of mass will be 3 meters from the end. And then it says it's resting on two sawhorses that are separated by 1.5 meters. And they're centered about the center. So how far is the center of mass from the fulcrum? It should be 0.75, right? Because it's centered about the fulcrum. So this should be 0.75 meters. And the board was 90 kilograms, I think. Throckmorton is out on the end, and this fulcrum is 0.75 meters from the center, and he's 3 meters from the center, so he must be 2.25 meters from the fulcrum. And so when you do the mass of Throckmorton, you should get 30 kilograms. He's just a little guy that this 90 kilogram board is gonna clobber in a second. Okay, so that's number 2. And the trick was that other sawhorse becomes useless. Number 3, we're going to run out of time on this one, but I can at least read it. An auto magazine reports certain cars have 53% of their weight on their front wheels and 47% on their back. And that should make sense because usually the engine is under the front. Okay, so I'm going to draw the wheels as these. Right, and so if it's supporting 53% of its weight, it means there must be an F rear and there must be an F front. Okay, to be continued in the next